Hi, so today we'll be solving some problems involving Coulomb's law and the superposition principle. So as a review, Coulomb's law states that Fe is equals to K absolute value Q1 times Q2 all over R squared, wherein K has a value of 9 times 10 to the ninth, and that is a constant. The superposition principle states that each charge will exert a force on another charge as if no other charges are present. So we will be solving in this video we'll be solving problems wherein the points will be in a rectangular position, and then the charges will be different from one another. So as you can see in these figures, we have points A, B, C, and D, wherein A is positive 2, B is positive 4, C is positive 6, and D is negative 8. So we will be solving for the forces exerted on point B. So let's first focus on the force of A on B. So using Coulomb's law formula, we have K, Q1, Q2 over R squared. So let's input values, and we'll get 9 times 10 to the 9, and Q1A, that's 2, then Q2B, that's 4 all over. So the distance between A and B, so since this is 3, this is also 3, so we'll have 3 squared. So let's simplify that, and we will get 8 over 9. So let's simplify further, and we will get 8 times 10 to the 9th power. So now let's go back to the figure and see in which direction this will be going. So as you can see, we should put this here: positive, 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 negative. So as you can see, A and B have the same sign, so they will be going away from each other. So B will be going away from A, going down. So the direction of this value will be down. Next, let's now focus on the forces exerted by C on B. So let's place our values: 9 times 10 to the 9th, Q1, which will be 4, then Q2, which is C, 6 all over. So the distance between B and C is 4, so that is 4 squared. So let's go simplify that. So we have 9 times 10 to the 9th, and here we have 24 and 16. So we can simplify it to 9 times 10 to the 9th times 1.5. Then the answer will be 1.35 times 10 to the 10th. So going back to the figure, we can see that B and C have the same sign too. So meaning B will be going away from C. So going that way to the left. So this will be left. Okay, now we will be focusing on the forces exerted by D on B. So as you can notice, unlike A and C wherein there's a direct path, B and D are not exactly beside each other, so there's no direct path from B to D. So that's why we will be using the diagonal of the rectangle, which is represented by this pink line. So in order to solve this, we need to find the length of this diagonal first. In this case, we can use the Pythagorean theorem. So let's use C is equals to square root of 3 squared plus 4 squared. So that will give us square root of 25, which means that the length is 5. So this is 5. So now we can start solving for the force exerted by D on B. Let's go back to the formula and input values. 9 times 10 to the 9th. Then Q1 is B, so that's 4. And Q2 is negative 8. That's D. Then R will be 5. That's the distance between them. Alright. 3. Yeah, okay. So the distance between them, 5 squared. So now we'll get 9 times 10 to the 9th. We'll have negative 32, 25. So remember, this is the absolute value sign. So because of this, we don't the negative will be gone. So now we will have the value 9 times 10 to the 9 times 1.28, with the answer 1.152 times 10 to the 10th. So now let's see the direction it will be going. So they have different signs. So B is positive while D is negative. So that means that B will be going towards D. So meaning going up there. So we can see that the direction will be going up right. So let's place that here. Up right. Okay. So now we need this value here that we have for the forces exerted by D on B. That's the value of this diagonal. But what we need is the vertical and horizontal components of that value. Thus, we will be using So in order to use so and ka, we first need to find an angle. So what I do is I use the TOA part, so that's tan theta is equals to opposite over adjacent, right? So the angle that we will be looking for is one that is against the horizon. So meaning we can either look for this one, because this is the horizon, so it's against it, or this one. This is also a horizon. We can use this angle. But according to alternate interior, they're both the same. So either way, it's the same. So first, let us manipulate this. So this will be theta is equals to, when you move tan to the other side, that will become tan -1. And then sorry. Okay. So tan -1, then we have opposite over adjacent. So let's go back. So the side that is opposite to this angle is this one. So that is 3. Let's go here. So that's 3 over adjacent. So the adjacent side is this. So that's 4. So 4. When we input that to the calculator, we will get the answer 36.86989765, or we can just say it's 36.87 degrees. Alright, so now we can look for the vertical and horizontal components of the force exerted by D on B. So for the vertical, we will have, so the force is 1.152 times 10 to the 10th, right? So we'll have we will have 1.152 times 10 to the 10th sine 36.87. So the answer to that will be 6.91 times 10 to the 9th. And going back to this one, it says upright. So since this is vertical, so this means this will be going up. Then for the horizontal component, we will still have 1.152 times 10 to the 10th. This time cos, because this is horizontal x, right? So we'll still have 36.87, and the answer will be 9.22 times 10 to the 9th. And again, going back to here, that's upright, so this will be right. Okay, now that we have that, we have to combine all these answers in order to get the resultant force. So we can draw a table here. to make it easier, so let's have vertical forces and have horizontal forces. Okay, so we have forces exerted by A, by C, and by D. So for A, we have 8 times 10 to the 9th down. So that means this will be vertical. So that is 8 times 10 to the 9th. This is down, so negative. Since it's going directly vertical, the horizontal value is just 0. So for C, we have 1.35 times 10 to the 10th left, right? So that is horizontal. So place that here, 1.35 times 10 to the 10th left, so negative. Then for D, your vertical and horizontal components, so that's vertical is positive, it's up, so that's 6.91. Oh yeah, for C, since this is also horizontal, so the value of the vertical is 0. We're going back to the D, so that's 6.91 times 10 to the 9th, so that's positive since it's up. Then for the horizontal, 9.22 times 10 to the 9th. So then we will just combine all these forces. So for vertical, so that's 6.91 times 10 to the 9th minus 8 times 10 to the 9th. So we will get the value of negative 1.09 times 10 to the 9th. Then for the horizontal, we will get the value of, we just combine these values. That's 4.28 times 10 to the 9th. Okay, so now that we have these are your resultant. So this is F Y, then this is F X. So now we need to find the angle that this will be going to, because this will basically be a diagonal. So first we need to find the angle that will be going. So let's see. Let's use tan theta is equals to opposite adjacent. So we can manipulate that and we'll get tan negative 1 opposite adjacent. So since we will be getting an angle that is against the horizon, the opposite will be the vertical. So let's put negative 1.09 times 10 to the 9 over adjacent, which is the horizontal value. So that is negative 4.28 times 10 to the 9th. And we will get the value of 14.28795313. So then now we can use either Pythagorean, but I just find it easier to use the so one. So that's sine theta is equals to opposite over